Address Resolution Protocol or ARP. What is this? How does it work? And what are the ARP important terms? You need to know, you need to understand. So this Address Resolution Protocol or ARP consists of address. What are these addresses? And which addresses need to be resolved? So there are two addresses. One is the IP address, one is the MAC address. So this Address Resolution Protocol is actually a communication protocol that is mapping the IP Internet Protocol or IP address to Media Access Control MAC address. Alright. RARP is also there, just a reverse of this. So why do we need IP and MAC, and why do we need some resolution? See, this is your house. Okay. IP address, Internet Protocol address, there is a router. So the location of your house is known. This IP address is about location, that this is the house and this is the router to which this Internet Protocol address has been assigned. Now here is you, your son and your wife. Now you are having a laptop, your son might be having a tablet, your wife may be having some handheld device or a computer. Okay. So there are three people in your house and they are having different gadgets. Now all the packet is going through that router. Alright. But till router, IP is okay. IP, a router. Right. But what about the person? That is the system. That is, you might be using Facebook, your wife might be using YouTube. So the packet of YouTube, when it comes to router, it has to go where? To YouTube, to your wife. The Facebook has to go to you. How will it go? Until you know the exact physical address of the machine. So IP address is like this. This is IPv4, Internet Protocol version 4. 32-bit of address it is. Then we have IPv6, which is 128-bit address. So these are two addresses which are the logical addresses, not the physical addresses. Okay. But the MAC address is a physical address. When your computer is, say, manufactured, and more precisely the NIC, Network Interface Card, is manufactured, the manufacturer has already put in a number which is physical, which is embedded. Okay. So this Address Resolution Protocol is a communication protocol used for discovering physical addresses. Physical addresses can be from Belkin, from say D-Link, from Cisco, and this physical address associated with a given network address. IEEE govern these type of numbers, that is MAC addresses. They know what number is coming from which company, and this is physical, and there cannot be two machines having the same MAC address. So first you have to go to IP, and then you have to find out the MAC address. So the protocol which actually finds the MAC addresses of the system using the IP address is the Address Resolution Protocol. Okay. Medium Access Control MAC address is the data link. So we talk about switch here, MAC, switch friendly, IP is router friendly. They work on different layers. So how does it work? How does this actually conversation take place, or this ARP works? Now see, what will happen is, so there is a computer, maybe in the same network, maybe in the different network. It knows its IP, it knows its MAC address. Okay. Now it wants to communicate with certain system B. It knows the IP addresses because it is known, because these are public IPs. If you are on the internet, you know the IP address, but the MAC address is not known. So ARP packet will be formed, and the formation will be something like this. There are certain matters, certain parameters here in the format, but the main format which you need to know is that the first ARP discovery message will go, and that will contain the MAC address of the system B, but you don't know it. So you have to write something. So ff.ff.ff.ff.ff is placed. That is the broadcast message. System A wants to know the MAC address of the other system. So it will send a ARP message with own IP with own MAC with IP of the system B without the MAC. So if it is not MAC, then it has to send some address. That is the broadcast address. That is why this ARP discovery is the broadcast message. Okay. But when the system will get that ARP, it will say, oh, he is talking about my IP. So it will actually put that MAC in the ARP reply. So the system A will send it to everyone, broadcast. But system B, when it will understand, oh, my IP is being my IP you are talking about, and my MAC you want. So it will reply with own IP, own MAC, and the other IP and other MAC. Okay. So this is your IP. This is the other's IP. This is my MAC. This is your MAC. So this is the reply will come. So when it will come, it will unicast. It will be unicasted when the reply will come, because the destination knows source is asking my MAC. So it will only send to the source. So this is how ARP works. So this is layer wise. You have a content coming from the application layer till the physical layer. In between we have network layer and the data link. So network layer IP, data link is MAC. Alright. MAC is a physical address. So you need to know a physical address along with IP in order to communicate. Getting MAC is the work of ARP. How does this address resolution protocol work? Now assume there is a person or there is a system. He knows his IP, he knows his MAC. Alright. Now he wants to talk to some other person. He knows the IP, but he is not aware of the MAC. MAC is the actual computer or physical NIC embedded address that is unique all over the world. So how does it work? This is the kind of actual MAC somebody wants through ARP. This is the IP known to both the parties. So ARP will come where? I will take some random say packet like ICMP. Okay, Internet Control Message Protocol. It only knows about or try to find out the network issues. But what is the scenario? You will see where the ARP will come. So this is the IP, known IP. This is the MAC, known MAC. Now there has to be a conversation between this IP 10.1.1.1 and 10.1.1.3. So what will happen? You need to know the MAC address, that is CCC, because you are aware of 10.1.1.1. This is yours. AAA is yours. IP is also known for PC3, which is 10.1.13, but the MAC is not known. So what will happen? Take an example of just simple ping. Okay, when you always ping. So you are pinging the PC3. Now when you ping, for example, ICMP message is there, ICMP, the source IP, destination IP, and the source MAC is known, AAA. But the destination MAC is not known. Here comes the ARP. ARP will ask, oh, this is IP. Whose IP is this? Please give me the MAC address. So this ARP will go to every system. This system will discard these messages. This is broadcast message. So now the 10.1.13 will say, oh, this is my IP. So I will give you my MAC. This CCC will go with the ARP reply. This ARP reply will be embedded inside ICMP, and then the other process will go on. So basically the IP is known, MAC is needed, or other person or other PC to communicate. That is how ARP works. Address Resolution Protocol, ARP. How does it actually go about? What will happen? First, just understand everything what is being showed here, then I will explain. There is a system A. Now he wants, I need the MAC address of this IP, some other IP. So it will send a request. I am asking, the system A will say, I am asking the person or the system 161.13.16.43. This is your IP. I want your MAC address. I want to send you some packets. Alright. So if I am a sender, there is a receiver. So if there is a switch, there will be a communication. Because the packet ARP will go to switch will forward it. If there is a router, that is the possibility there are two different networks. So router wise router it will go. One source and one destination. Source is not directly asking the destination. It has to send the packet ARP to router. Router will again send another packet to another router till the destination is reached. So before ARP can start, address resolution protocol can start, you need to know ARP-A. If you just put it on the command prompt, you will see the listing that is called the cache. So if you already sent a ARP packet and you have already mapped the internet address or the IP address with the physical address, which is the MAC address. Okay. IP address 32-bit address, logical address. MAC is the 48-bit, the physical address. So dynamically it has come, that is through ARP. Static is actually you have actually entered, sitting, manually entered. So this dynamic, it is already there, static already you have filled up. So what is the point in sending ARP when the mapping is already there? So first the cache will be checked. Oh, I want to communicate with this IP. Do I have the MAC address? Oh, I have it. No ARP will be sent. But if the cache is not having that IP to MAC mapping, it will send an ARP request that this is the IP, I want the MAC address. Okay, this is called the ARP discovery packet. But it is broadcast because we don't know. We have to send it to everyone. So everyone will get either inside the network or outside the network, everyone will get this ARP discovery packet. But when the system which actually has this 161.13.16.43, it has to revert back. It will know, oh, this is my IP. So it will send an ARP reply. So the logical address, which is the IP address, the MAC address, which is the physical address embedded inside the NIC, it will be sent in the ARP reply to the asking system, asking computer. So NIC card has a MAC address, IP address along with the MAC address, that is the medium access control layer. This address has to be combined. Only then this can be communicated. There are different important ARP terms. There are certain terms connected with ARP. ARP is address resolution protocol. The first thing goes is ARP request. So there is a proper format of ARP. Most of the things are there. So if I know the IP of my system and MAC address of my system, if I know the IP of another system, but MAC is not known because it is a physical address inside the NIC card, so I have to send an ARP request. So broadcasting a packet over the network to validate whether we came across the destination MAC address or not is the ARP request. It is broadcasted to everyone. But before sending the ARP, we need to check in our cache that whether we have already the mapping of this IP, that is we already have the MAC or not. Otherwise, why would we flood or congest the network? Once it is done, ARP response or reply is the MAC address response that the source received from the destination aids in further communication of the data. That is, the unicasting will be done from the destination to the source, that this is what you wanted, my MAC address, take the MAC address. Then the ARP cache, after we resolve the MAC address, the ARP sends it to the cache stored in the table for future reference. The further or the subsequent communication can use the MAC address from the table already being created, and this is the cache. Finally, there are multiple dynamic messages here, and one time it will be too much, so they have to be deleted. How to delete this dynamic mapping or the cache content? It is the time for which the MAC address in the ARP cache can reside. After that, that dynamic will be released. It will be deleted. Static will remain there because static is actually inputted by the network administrator. Okay, for what time this content will remain here? The dynamic ones will be the ARP cache timeout. Let me tell you again, a machine have a IP address, have a MAC address. He or she wants to communicate with any other machine whose IP is known, the MAC address to be known, because this is a physical address that can only come through ARP. ARP is all about that only. This is all about address resolution protocol. Thank you so much. Take care of yourself.